Yeah, that's what I was going to say. Gotta have something.
Right.
All right, so we're in chapter 4, 4.1. So we're going to talk about radians and degrees. And I know that we've seen some of these ideas, or a good part of these ideas in the past in geometry and in Algebra 2. We're going to go a little further, quite a bit further, and a fair amount deeper than you've gone in the past. Getting you so you have the calculus, the trigonometry tools that you'll need for calculus. Like I said before, the pre-calculus means getting you ready for calculus. First off, what's an angle? Think back to geometry. What makes up an angle? Two lines, and let's be a little more precise. Think how precise you were in geometry. Two rays. So an angle is made up of two rays. And what do those two rays have to do to make an angle? They have so they're, what do we call it when they meet? Intersect, our fancy math word, intersect. So an angle made up of two intersecting rays. So what I want to do first, let's draw a picture. This is our coordinate system, our x and y axis. And we need to talk about some terminology, because we use words in a specific way. When you get homework problems, they'll ask about in very specific ways. So let me draw an angle here. We're going to put one ray right along the x-axis, and I'm going to make the other ray go up that way. We call, and someone said our word for this point where they come together, or where they intersect, what do we call that? The vertex. So this is the vertex. We call this side the initial side. And this other side is the terminal side.
How do you tell which one is
And so the problem will tell you one way or the other. So an angle with its initial side, such and such, and it'll make a description. And this is the y-axis and the x-axis. So there's our angle, initial side, terminal side, vertex. The measure of the angle is how much we're rotating. That's how we measure the angle. The measure it talks about the rotation. We usually call our angle, our measure of rotation, in trigonometry we like this symbol theta, just a Greek letter. I don't know why they picked theta for angles, but that's what they did. Kind of tradition. We call a rotation. Let me back up one little bit here first. An angle with its initial side on the x-axis and its vertex at the origin we call it standard position. So that's one way they would tell you where the initial side is they would say an angle in standard position. That means its initial side's on the x-axis and its vertex is at the origin. When we rotate counterclockwise, we call that the positive direction. So positive is counterclockwise, negative is clockwise. So positive angle we're going clockwise, and negative angle we're going positive angle we're going counterclockwise, negative angle we're going clockwise. The quadrant of the angle So we have an angle in standard position. Sometimes you'll get questions about the quadrant of the angle. Quadrant of the angle is asking us or telling us where is the terminal side. So if we have an angle in standard position, they say it's a second quadrant angle. That means the terminal side is in the second quadrant. And remember, our quadrants go counterclockwise also, so this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then later on, we'll talk about three-dimensional coordinate systems, and we'll have octants. We have 8 octants instead of 4 quadrants. It's kind of fun when we get that. All right, we good with this terminology so far? Another term that we'll see fairly often, and it's a fairly important idea, is coterminal angles. So, what do you think we mean by coterminal? What does co mean? Two or together? So we're talking about together and the terminal. We talked about the terminal side. Exactly. So a coterminal angle just means the terminal sides are in exactly the same place. And we'll talk about how we find specific coterminal angles in a little bit. Yes? Right. So, and we'll talk about that in just a second too. So, but yes, you're exactly right. All right. So we're good with our terminology so far. Now in trigonometry, we like to, and I know that you've worked with it a little before. We like to measure angles in radians rather than degrees, because degrees are kind of an arbitrary division of the circle. The radian is a more natural division of the circle. So that's what we're going to talk about next. We'll talk about what a radian is, and then we'll actually do some work with these angles. But just to kind of get us thinking here, what do we know? Do we have an idea? So we have 360 degrees in a circle. Why do we have 360 degrees in a circle? Where did that number come from? How many days are there in a year? 365. Those two are kind of related. Takes the Earth 365 days to go around the Sun, and it's 360 degrees in a circle. So it has to do with subdivisions basically based on the season. And 360 and 365 has to do with something to do with the number base that the Egyptians like to use. That's kind of how it started. Did you have a? Okay. But we want something a little less arbitrary than that has to do with how we measure the season. The radians are a little less arbitrary. So let's draw another picture of our angle in standard position. And now we're going to think of this angle as, we're going to think of rotating this ray up this way. So as we rotate this ray, it's going to trace out part of a circle. So we're going to end up here like so. And we're interested in this little piece of the circle. So here's our angle, theta. and we're saying this is this ray rotated up this direction, and we're going to talk about the radius of the circle. So this is a piece of the circle. We're rotating that angle or that ray around, so each of these is going to be the radius. And we're interested in the arc length also. Normally we use the symbol S for arc length. And I try to draw my S's curvy so they don't look like 5s. When we talk about radian measure of an angle, we're talking about the ratio of the arc length to the radius. So as the arc length gets bigger, as we travel further along this arc, that arc length gets bigger, the radius stays the same, so our angle gets bigger. So we're talking about that ratio. That's what radian measure is talking about. Is we're talking about how far we've traveled around that circle when we make a ratio with the radius. One of the nice things about radian measure, arc length and radius both have the same units. They're units of length, inches, meters, centimeters, something. So when we take arc length and we divide it by radius, the units cancel out. Radians don't have any units, so we don't have to worry about the units. So that's one nice thing about working with radians. There are no units. One radian is when the arc length equals the radius. So if we rotate around here and this arc length were exactly equal to the radius, that would be 1 radian in our circle. So that's 1 radian when the arc length equals the radius. What's a special name that we give to the arc length all the way around the circle? The circumference. So I'm going to say the circumference. How do we find the circumference of a circle? What's our formula? 2 pi r. The circumference is 2 pi r. Well, the circumference is the arc length. So S equals 2 pi r. And divide both sides by r. S over r equals 2 pi. So how many radians are there when we rotate around an entire circle? 2 pi. So radians are more closely related to the properties of a circle than dividing it into 360 pieces. It has to do with this fact that pi is this nice ratio that never changes for circles. So we have 2 pi radians in an entire circle. 2 pi is about how many radians? 2 times pi is about 6. It's like 6.28. So about 6 radians in an entire circle. So half a circle is just slightly less than 3 radians. So if we took a piece of string, the length of the radius of a circle, we could lay that string around the outside of the circle roughly 6 times. So there are about 6 radians in a circle. The arc length makes that's the same as the radius defines 1 radian. So that's kind of the background on radians and what they are and why we want to use them rather than degrees. Let's talk about some other common angles. If we have 2 pi radians in an entire circle, how many radians are in half a circle? Pi radians. So I'm going to write a few common angles. And pi radians in degrees? 180. Half a circle. How about a quarter of a circle? 90 degrees or in radians? 1/2 pi or pi over 2. We usually write pi over 2. And I'm writing RAD for radians. Usually we just leave the units off. We don't even write RAD. 90 degrees. How about 3/4 of a circle? 270 degrees. And in radians? 1.5, and as a fraction? 3 pi over 2. So how about 45 degrees? Pi over 4 radians. And what would be 1/6 of a circle? How many degrees? 60 degrees. And in radians? 2 pi, 1/6 of 2 pi is pi over 3 radians. And we'll get very familiar with these over the course of the semester. So and what we want to start doing is being able to think in radians a little bit rather than think in degrees. All right. So we want to do a few things with what we know now about trigonometry, about angles and circles and triangles and etc. So in trigonometry, what we do a lot is, often in math, we like triangles. We like triangles because the Pythagorean theorem works, and we like circles because they're a nice, simple shape. Often we try to turn problems involving shapes into problems involving triangles, and when we can, part of what we do with trigonometry is turn problems involving triangles into problems involving circles. So that's part of what we do in trigonometry. And we'll make the relationship, the connection between the triangle and the circle a little stronger as we go on. All right, so let's talk about a few more terms. Let's back up to coterminal angles really quickly. Let's talk about finding coterminal angles. So we said coterminal angles means that the terminal side is in the same place. And Jameson gave us an idea of how we find coterminal angles. So if we're on a circle here, and I have an angle in standard position, and here's my terminal side, what would make a coterminal angle with this one? How far around would I have to rotate this angle for the terminal sides to be in the same place? 360 degrees, or in radians? 2 pi. So to find a coterminal angle, what did you say we did? Okay, and if we wanted to go in the positive direction, we would add 2 pi. So if we're given an angle and it says find a positive coterminal angle, just add 2 pi to it. Or 360 degrees if it's in degrees. If we want a negative coterminal angle, we just rotate around the other direction. So instead of rotating this direction, we rotate around that direction, and we subtract 2 pi. And we could add or subtract any multiple of 2 pi. So if we add 4 pi, we're just going around the circle twice. Negative 4 pi, we go the other direction twice. So we should start thinking about 2 pi telling us go around the circle. We add 2 pi, we're going around the circle again. That'll be a big theme. All right, what is an acute angle? An acute angle is less than 90, and in radians? less than pi over 2. And we don't want it to, for all of these next ones, we don't want it to be negative. So we're going to say between 0 and pi over 2 radians. How about an obtuse angle? So more than between pi over 2. What we say is we kind of ignore this bottom half of the circle, so we're going to say that an obtuse angle is between pi over 2 and pi, because we do something else with these angles down here. So we want our obtuse angle to be between pi over 2 and pi. Usually we think of obtuse angles being larger than 90 degrees or larger than pi over 2. But here it's between 90 and 180, or between pi over 2 and pi. So if we want, what are complementary? What are complementary angles? They say nice things about each other? Hold that one for the next question. So what would the other one be? Complementary, if it's not 180, then it would be 90, or in radians? Pi halves, pi over 2. So if the problem asks you to find the complement of some angle, you subtract from pi over 2. And again, we're talking about positive angles here. Negative angles don't have complements, negative angles don't have supplements. The next one we'll talk about is supplementary angles. And what are those, Ben? Add to 180, or in radians? Add to pi. So if we want to find the supplement of an angle, we subtract it from pi. So most of the day is kind of reviewing some terminology and getting to where we can think a little bit in radians. All right, so let's talk about conversion, how we convert from degrees to radians. So degrees. One degree is the angle that is 1/360th of a circle. So we can use this idea that 360 degrees in a circle, 2 pi radians in a circle. We can come up with our conversion. So we have 2 pi radians equals 360 degrees. So if I divide both sides by 360, I get 1 degree equals pi over 180 radians. So to convert from degrees to radians, I multiply by pi over 180. And if I want to convert the other way, radians to degrees, and I'm going to use an abbreviation here, we're going to multiply by 180 over pi. All right, so let's look at a couple of these, because often with these kinds of problems, they'll say convert from radians to degrees without using a calculator, or give an exact answer, or something like that. Whenever you see a problem like that, that should be a hint that there's a trick to it, or that there's something more that you know about it than just plugging it into your calculator. So let's do a conversion. Everybody good with how we came up with this conversion? Okay. Just a couple quick examples here. Let's say we want 120 and we want to convert 2 radians. So we're going to do 120 times pi over 180, and we want an exact answer, or we want to not use our calculator. What that's asking us to do is reduce this fraction. So what does that fraction reduce to? 120 over 180. 2/3. So 2 pi over 3 is what we'd write. So that's what this problem would be asking us to do. This is without using the calculator. If we want to go the other way, 5 pi over 6. And we want to convert 2 degrees. I'm going to multiply 5 pi over 6 times 180 over pi. Our pi's cancel, and then I want to reduce this fraction. So what is this? When I do this arithmetic, what do I get? The pi's cancel. Six goes into 180 how many times? 30, right? 5 times 30 is 150 degrees. So those kinds of problems, when it says give an exact answer or don't without using your calculator, it's asking you to work with those fractions. Everybody good there? Okay, pretty easy stuff, I think. One thing I want to show you on your calculator is sometimes in navigation and in surveying, you'll see an angle that looks something like this: 37 degrees, 18 minutes, 28 seconds. They call this degree, minute, second form. And 1 minute is 1/60th of a degree, and 1 second is 1/3600th of a degree. So we could do this conversion by hand. Multiply 18 by 1/60th, turn that into a decimal. Multiply 28 by 1/3600th, turn that into a decimal. Add them together. Kind of tedious, but our calculator does it really nicely for us. So let me show you the key strokes on your calculator to do this conversion. Some of the problems have the angles in this format. So there's our calculator. And I said 37 degrees. So I'm going to do 37. And then I'm going to go to the angle menu. The angle menu is above the apps button. I'm going to hit second and then that apps button. And then that first one is degrees. Go ahead, enter. There's 37 degrees. And then, did I say 18 minutes? 18 minutes. So I'm going to do 18. Go back to the angle menu. The second one is minutes. Hit enter. There's my 18 minutes. And then the seconds, what did I say, 28 seconds? 28. 28. The seconds are not in the angle menu. They're down here above the plus button. So the little green ones by the plus button here. So I do alpha plus. There's 37 degrees, 18 minutes, 28 seconds. I hit enter, and that's 37.308 degrees. So our calculator will do that conversion. If I want to go the other direction, if I want to convert this back to this form, I can go back to that angle menu, and this fourth one is the conversion 2 degrees, minutes, seconds. So I hit enter again, and it converts this back into 37 degrees, 18 minutes, 28 seconds. So some of your problems have to do with that, and that'll be the case throughout the semester. You'll have some problems that have this format. All right, questions? Okay. Homework. There we go. Every third. And I apologize in advance. I tried to correct all of them where I made a mistake last year, but sometimes when I counted these out, the last number isn't the next every third. If that happened, just stop at the one before. I try to fix them all. Sometimes mistakes get made. Okay. Did you guys